Hello, my name is Matt Radizak, and I'm an NX CAD application engineer for Prolim PLM. Today we're going to be covering assembly constraints in this webinar. Moving to our agenda for today, we're going to be talking about positioning and constraining parts, the different types of constraints you have available inside of NX to use, as well as joints, which were added in a previous version, how you can modify those constraints and make changes to them, and how you can reuse those constraints for parts that are going to be repeatedly brought into an assembly. So the first thing I want to talk about is our methods of positioning. So within NX, when you bring a new component in or start an assembly, you have two options for how you would like to move that component in space. You have absolute positioning, which is where you can simply move that component in 3D space. So you have handles in NX where you can grab those handles and drag and move the part around in space, rotate it, move the handles around and choose how you want to orient the rotation axis and all that. So that's how you can control them apart in 3D space and move it around freely. Now, the other option is through the use of assembly constraints, where you create constraints for that new model that you just brought in and constrain it to other models within your assembly. So you say create a touch line on one face of a model to another face of a model to move it to where that other model is located. Now, typically when you first bring in a model, the very first model of an assembly, you'll create a fixed constraint to lock it in place. That way it acts as the centerpiece for the rest of the model, and then you then constrain your other models to that piece. Now we're going to talk a little bit about different constraint options that you have within NX. So the ones we're going to go through today are touch line, concentric, distance, fix, parallel, perpendicular, align lock, fit, bond, center, and angle. And then we're also going to go over joints, which are kind of like hybrid constraints that do like multiple constraints at once without having to create those different constraints. And those four are hinge, slider, cylindrical, and ball. Now, jumping over to NX, I'm going to be taking a look at some of the things we just talked about, specifically starting with how you can position and constrain components inside of your assemblies. Now, coming into this add component command, I have the ability to come in and bring components into my assembly while also being able to constrain them on the fly. So I'm going to go ahead and hit browse and pick out my part. And you'll notice that I have the ability to move this component around within that component. So I have a couple different options for how I want to place it. So the first option is my location settings. So how do I want this part to be brought in immediately? So I can choose to have it brought in through the work part, the displayed part, or the WCS. And this will all snap it to the origin of those locations. Or I can snap the component in. So say I wanted to place this component starting out on the corner of another component. I could select that corner and use that as a placement option. And this isn't a constraint or anything. This is just where do I want to bring this component in. So say, for instance, I bring this in and I want to snap it to a position, and I want to move it, say, 5 millimeters down the X axis to help position where I want it to be positioned. What I could do then, I'm going to go ahead and change this back to work part. I could then come into placement, move, and I can move it along that axis using this drag handles that you commonly see within an X. So you have the ability to place them that way if you would like. Now, if you say you wanted to bring a component in and immediately start constraining it, you could set this to constrain and then create your constraints on the fly within the add component tool. Since this is my first component, this is going to be fixed anyway. So I'm just going to go ahead and hit OK. NX will then give me a warning message saying you just added your first component. Do you want to create a fixed constraint? Yes, I do. Since this is my first component, I want everything to constrain around it. So I'll go ahead and confirm that. So now I have a fixed block. You can check to make sure it's fixed by clicking Show Degrees of Freedom. And you see there are no red arrows here. And I'll show you what this looks like later when you have degrees of freedom available. But in this instance, there are none available, so we know that this component is locked in place. So go ahead and bring a new component in. And this time I'm going to be bringing in the S plate. I want to bring in just the S plate. So if I want to bring in multiple components, I could by simply selecting multiple in this loaded parts as well, if I wanted to. And I'll show you what this looks like here in a second when we bring in another S plate. So for this component, I'm going to create a couple constraints. I'm going to use some basic touch align constraint. So with this one, I just select two faces, and it creates a touch alignment between the two of them so that they are touching. Now, say for instance, they weren't aligned properly, and say this was self-intersecting with the other model, I can hit this reverse last constraint button, and it'll reverse the position of those two faces. So it'll help me with constraining the model when I put my first constraint, if it's not exactly what my design intention was. Now I'm going to create a concentric constraint, and I want to use the circular edge of this C head here, but I don't actually have a visual of it. So what I can do is I come down here and uncheck preview, and then I can simply grab it. So you have some tools in here within the add component that help with placing those different constraints that you wouldn't have with the assembly constraints command. Now with that, I'm going to go ahead and grab this edge here, and we'll create that concentric constraint. Now you might think this is fully constrained, but it actually isn't. If I go ahead and confirm this, and right click and do show degrees of freedom, it still has that rotation axis around that concentric constraint, because the concentric constraint doesn't lock that rotation. So in order to fully constrain this component, I need to create one more constraint to lock it into place. So I'll come into my assembly constraints, and I'm just going to make a parallel constraint between this face here and this face here. Confirm that. Now I'll update display and show the degrees of freedom once more just to confirm. And you can see that there are no red arrows here showing that it has a rotation axis there. So the component is fully constrained. Now with this next component I'm going to bring in, I want to show you that your constraints can be used in different ways depending on what your design intent is. And you can also have more or less constraints depending on which constraints you use. So if I go ahead and bring in another component, I'll just bring in another S plate. This time I'm going to be using distance. So I'm going to use the distance constraint using this face and this face, just to show you what this looks like. So you can grab your geometry and constrain it via a value. So instead of it being a touch line, I'm specifying a specific distance between these two faces. Now I can control that from here. So if I wanted to change this to 0 for now and leave it like that, I could. So now I have a 0 millimeter distance between those two faces, which would be the same as a touch line. But say I wanted a 3 millimeter distance, I could set that as well. In this instance, I'm just using this to show you that the distance command exists so that you could use it in this kind of instance. So I'll leave that value as 0. Now I'm going to set this to a line lock, which is a variation of the concentric constraint. What this constraint does is it allows me to lock the axis of rotation while also creating that concentric constraint. So go ahead and turn on preview, and then select my edges. And you can see that it creates that same concentric constraint, but when I confirm this and come into show degrees of freedom, doesn't have that axis of rotation. So I only use 2 constraints in this instance to lock the component down versus the previous one where I used 3. So you have different options for how you want to constrain it depending on what your design intent is for that component. Now I just want to show you a couple more different constraint options, and then we'll go through the ones that I didn't show as well, just so you know what all is available to you. So I'm going to go ahead and bring the pen in. And I want to bring just the pen. So now what I'm going to do is I'm going to use the fit constraint. And what this does is it creates a concentric constraint for 2 objects with equal radii. So as long as they match up, it'll fit well and work well. So I'll go ahead and select this face here and this face here. It creates that fit constraint. And then I can create my touch line between this face here and this face here. So I have that fit. Now the other options for constraints that you have available to you, I'm going to go ahead and go into the assembly strengths command because there is a difference between the different options. So within your assembly constraints, you have access to touch align, concentric, distance, fix, which is the one we used when we first brought that first component into our assembly, parallel, perpendicular. So if I wanted to create two components that are perpendicular or bring a component in and constrain it to a perpendicular angle with another component, I could do that. Align lock, fit, bond, which constrains objects together so they move as a rigid body. Center, this allows me to select one or two objects and place them between a pair of objects. So say, for instance, I wanted to center this pen between these two S plates. I could select a pen, select these two faces, and it would center that pen between the two of them. And then there's also an angle constraint, which we'll show a little bit here in a bit when we start talking about joints. Now, joints and couplers, these are some different constraints that are more like a combination of constraints. So they allow you to create multiple constraints at once without having to create them manually. They're more complex in that avenue, so they take a little bit more selection, but they end up helping you in the long run with managing your constraints and how you want to place different types of joints. Specifically, we won't talk about couplers today, but we will go through each of the four joints, and I'll give you some examples of what they could be used for. Now, you might notice that these joints are available here, but they weren't available in the add component command. You'd be correct in noticing that. The add component command does not currently have those joint options available within it. So I only have the option to constrain it through the typical constraints, not the joints and coupler options. Now we're going to move into joints. Now I'm going to go ahead and open up a new assembly for this. Go ahead and create a new assembly, And I'm going to bring in a component for the hinge, is what we're going to start with. Bring in my base part. Just going to confirm that, create a fixed constraint again, just like before. And now when I bring in the second component, go ahead and hit OK, and then get into my assembly constraint so I can go ahead and make that hinge joint. So when creating a joint, all you do is you select your hinge, or the joint you're going to be planning on using, and then every single one of these joints uses the same requirements for the geometry to constrain. It requires an axis on the first object and an axis on the second object. And when selecting these, be mindful of what you're selecting. So, for instance, I'm going to create a joint along this center rod here where there would be a rod. Now what I'm going to do is I'm going to select the vector for this. So I'm going to select that face, that internal face, and I'm going to select the point. So I'm going to pick the center point of this arc. Since I selected the center point of that arc, I want that to be concentric with the center point of the hole on this arm. So I'm going to go ahead and select this as my vector, and then select this as my point. Now when I go ahead and hit create joint, it'll create that joint, and it has that angle dimension there that you can see. Now I can control that angle and move that component. So if I go ahead and confirm this, and go into move component, you can see that once I select my component, I can drag this up and down. Drag this up and down to move it along that angle. And you can see the number changing over here on my hinge joint constraint. Something else I like to mention, since we're in the topic of moving, constraining, and positioning your parts and assemblies, the move component also has a cool little feature for collision detection. So if you expand settings and come down to collision detection, you can turn on highlight collision, and then it'll highlight when there's a collision between your components. You can also have it set to stop before collision. That way, if it's going to collide, it'll just stop where it would have collided. Okay. Simple as that. Now, say I wanted to lock this. So say, for instance, maybe I didn't want it to go below 0 degrees and above 90 degrees. What I could do is I could come into my hinge. So if I go to my assembly navigator, constraints, and click edit for my hinge, I can come in and give it angle limits. So I can set upper and lower limits for this constraint, or for this angle that the hinge is creating. Go ahead and hit OK. Now when I move this component, you'll see that it locks out at 0 degrees. Oh, it's because I had the vectors flipped for the negatives. So above, technically up here is -90, and down here is +90. So it's only going to let me go between these two. Let me go ahead and change that real quick. So I'll set this upper limit to 0 and this lower limit to -90. Go ahead and hit OK. Now I can move that as I see fit between -90 and 0. Now that's the hinge. There is another component here. You'd put a rod through there, but that we don't really need that to show the hinge constraint. I just like to show you the different joints to show how you would apply them and use them in an actual context. So we're going to move into the next assembly, which I believe there's already an assembly created for this one. And we're just going to be looking at this slider. And we're going to be using this same assembly for 2 different types of constraints. We're going to be showing both the slider and the cylindrical joint. So I'm going to go ahead and select the slider. And I'm going to pick my vector and point. So pick here, pick here, pick here, and pick here. Create the joint. So then the joint is created. Now when I go into move component, I can drag this up and down along that axis, that shared axis. And then again, I have the ability to control the limits. So if I don't want it to be able to extend past the length of this rod, I could then create a limit, a translation limit within the joint. And you can even use variables to control that. So say I wanted to create a variable for this arm length here. I could use that variable for the duration of that limit if I wanted to. Now, something I like to show between the slider and the cylindrical, since they're similar concepts, is the slider acts as a translational movement only with no rotation. So if I go ahead and right-click and do show degrees of freedom, you can see it only has that translational degree of freedom, that up and down along the z-axis. Now, if I were to go ahead and delete that constraint and create a new assembly constraint for cylindrical, again, just selecting my vectors and center points. Create that joint. Now when I go into my degrees of freedom, you can see it has that rotation axis, so it can rotate around that z-axis. So that's the difference between your cylindrical and your slider. Depending on what you're trying to do, you might want one or the other. And for the final one, the final joint, we're going to be looking at a ball joint. Now with this one, it's a little bit more difficult to place the point because you actually have to go into the point dialog to grab the center of the sphere. So I probably need to delete this, yep. For this, I'm going to be selecting the first axis. So I'm going to be selecting the axis of this for my part 1, my base. And for my point, I'm going to do the center of that arc as well. And now for my vector on the sphere, I'm going to be using this arc here. And then for my point, I need to grab the center point of the sphere. But obviously, I can't really grab that center point. So I'm going to go ahead and go into my point dialog, where it gives me some more options for how I want to grab my point. And one of those options is sphere center. So I can select that, select my sphere, it'll give me that arc center, and I'm back out into my assembly constraints. Now when I hit create joint, it'll create that ball joint. And what the ball joint does, it locks it in that single space and locks on translational movement, but leaves all degrees of freedom for rotation. So I can rotate about any axis. So if I go ahead and hit OK, you can see I can rotate that around any axis. And again, I can use move component to show that, and then even have collision detection. So if this head here collides with the base of the model, it'll highlight or block stop movement when it collides with that base. Now, jumping back to our PowerPoint slides, we got 2 more slides to get through, and then I'll show some examples of what I'm talking about for each of these different concepts. So the first thing we're going to talk about is how to modify your constraints. So within your constraints, you can go back in and modify them after the fact. So you can either redefine, reverse, convert, suppress, rename, hide, or delete the constraint, and then you also have the option to see some information about that constraint. Some of these things you might have noticed I did when we were going through the different constraints. I deleted a couple. I never renamed or hid any of them, but we'll go over each of these different options. And then you also have the ability to reuse constraints, and this is very handy for when you're bringing in a number of components that you might need to that are going to be constrained in similar fashion. So say, for instance, a few pins was what I'll be using as an example when I show this. You might bring in one pin and create the constraints for one of them, and then you want it to remember those constraints when you bring the next pin in. So then when you bring that next pin in, you can simply go through the different constraints that are listed and constrain that pin accordingly to the geometry in the model. So it makes it a little bit easier to constrain that component the next time you bring it in. Now, hopping back over to NX to show our last 2 topics for this webinar, I'm going to be going through how you can modify your constraints pretty quick. So jumping back to our carrier assembly, I'm going to go through these different constraints that I've already created and just talk about the different options you have on how you can modify these. So for instance, this touch constraint, if I wanted to redefine it, I can right-click and select redefine. And what redefine does is it allows me to redefine the objects that I'm going to be using for this constraint, as well as what type of constraint it was. So this is like a more or less, I'm editing the constraint. I'm changing how I want this constraint to work, whether it be what type of constraint, whether it be the objects used by the constraint, or whether or not I want to reverse the outcome of this constraint. So it's a general edit, so to reopen that constraint and modify it. What I can also do is I can do a reverse constraint. So if I were to come into this parallel here and hit reverse, you can see it reversed the outcome that resulted in the same constraint, but it's a different variant. So it's the same as if I were to go into redefine and click that reverse button, right? It's just reversing the outcome in case the design intent wasn't shown when I first created that constraint. So I can reverse that. I can reverse it back simply by right-clicking and reversing once again. I also have the ability to convert to. So for instance, if I wanted to convert this concentric to a line lock, I could do that. And what you'll see here is this convert to option will change depending on the type of constraint you're changing. So for instance, with this concentric, it only lets me swap to a line lock. But if I were to right-click on a line lock and convert to, I'd be able to change it to a touch, concentric, distance, angle, parallel, perpendicular. And it's because of the things that I selected using the constraint, as well as what the constraint requires to create it. Now I also have the ability to suppress constraints. So for instance, if I wanted to change this concentric to a line lock, I would no longer need that parallel constraint, right? So if I were to convert this to a line lock, this parallel constraint is now obsolete, so I could then suppress it. So it now has no bearing on the model, since it would have just been a redundant constraint to have that parallel constraint there. I also have the ability to come in and delete these, so I can select delete, and it'll remove that constraint from my constraint list. And I also have the ability to hide them. So say, for instance, you get tired of seeing all these little blue lines showing these different constraints. Let's say I wanted to hide this. I can right-click and select hide. I can also select them in the display window and hit Control B and hide it like so. So those are some of the different options within your constraints. You also have the ability to rename it. So for instance, if I wanted to keep better track of my constraints to understand what's going on in my list of constraints in my assembly navigator, I can rename them to better show what my design intent was with that. And then finally, we have an information dialog where we can click and see the different information about that constraint, when it was created, whether or not it's suppressed, some various different information. Just a typical information window within an X. Now, the last thing I want to show and talk about is how you can reuse your constraints. So we already added one of these pens. I'm going to go ahead and bring in another one. And I'm going to create a few constraints here. I'm going to create a concentric constraint between this edge and this edge. And I'm going to create a touch alignment between this edge and this edge. Or this face and this face, sorry. I'm going to go ahead and confirm that. And I have my pen. Now what I want to do is I want to remember that constraint. So I'll go into Remember Constraints, where it remembers assembly constraints and parts for reuse in other components. I select my component, and I select the constraints I want it to remember. So it'll be these two. Confirm that. Now, when I go to add a new component, i.e. the pen, the selected components have remembered constraints defined. If you do not constrain these components, then the inputs for the remembered constraints can be defined after OK. After I hit OK. So go ahead and hit OK. And it opens up a redefined constraints window. And then it shows me how these constraints were created. So the align constraint over here in this preview window shows that this face had already been selected. So when it's prompting me to select the object that I want to touch align with that face, i.e. I'm going to be using this face here. Now it wants to use the concentric constraint, and you can see I can zoom in and out of this component and see where it's defined. So I know I want to select this concentric edge. Once I've selected everything I want, I can hit OK, and it'll place the component accordingly. So it's just a way to make placing the constraints easier, or placing the components easier, because it recognizes those constraints were already created and saves you a few clicks down the line, since you are going to be, say, placing 4 or 5 of these at once. And that wraps up today's webinar. Thank you all for attending. Again, my name is Matt Radizak. And if you would like to rewatch this video or any of our other videos on Solid Edge, NXCAM, or Team Center, as well as our NXCAD videos, you can check out our YouTube channel, Prolim PLM. And we'll be opening this up for Q&A. So thank you for watching this video and attending today's webinar.